Hi everyone, welcome to the second class on proportion. I hope you have watched the first class and you have practiced some questions as well as solved the questions once again that we did in the class. So today in proportions, we'll continue from where we left. If you remember, what we did in the last class was we defined that anything of the type A is to B is equal to C is to D is what we call as a proportion. This can also be written as A is to B is as C is to D. This is a proportion which in a fraction form is written as A by B is equal to C by D. Okay, and B and C are called means, A and D are called extremes, and as you can see here, your product of the extremes is equal to product of the means. Also, A is called the first proportional, B is called the second proportional, C is called the third proportional, and D is called the fourth proportional. Then we also discussed some more properties of proportion, which is invertendo, alternando, componendo, dividendo, componendo dividendo, and summation. Okay, and we had solved some questions on them as well. So today we'll continue from there and we will look at the concept of continued proportion. Okay, so very important definition. A list of terms is said to be in continued proportion if the ratio between successive terms is a constant. Understand this very carefully. So A is to B is equal to B is to C is equal to C is to D. This is a continued proportion. Okay, you can see that ratio of successive terms. So this is the first. So basically first term upon second is equal to second term upon third is equal to third upon fourth is equal to fourth upon fifth. You can stretch this as much as you want. But if I just focus on this much, ratio of the first term upon second is same as second upon third, hence it is a continued proportion. So ratio between successive terms is a constant. That is the important part here. Okay, so you can see here A is to B is equal to B is to C. Okay, so then A, B, C, D will be said to be in continued proportion. And when that happens, when A is to B is equal to B is to C, which is same as saying that A by B is equal to B by C, when that happens, then understand these now few terms very carefully. A is said the first proportional as earlier, B is the second proportional, but B becomes very important because B is getting repeated. So it is called the second proportional. It is also called the mean proportional. It is also called the middle proportional. So second, mean, middle, whatever you want to call it. And then C will be called the third proportional. So in this case, you'll have only three proportionals. D is missing. So because B is getting repeated. Okay. Also, from your product of means is equal to product of extremes concept, if you cross multiply them, you will see that B is the mean in both of them. So you'll get B square is equal to AC. You'll get B square is equal to AC here, which is a very important property of a continued proportion. So between first and second, B square is equal to AC. Between second and third, C square is equal to BD, and you'll continue getting like this. Okay, the mean proportional will always come in square. Okay, and then the third concept here is that your product, the ratio of the first and the third proportional is equal to the duplicate ratio. Now, what is a duplicate ratio? When we discuss ratio, when you write a ratio of A is to B, okay, then A square is to B square is called the duplicate ratio. A cube is to B cube is called the triplicate ratio. Okay, also under root A is to under root B is called the subduplicate ratio, and cube root of A is to cube root of B is called the subtriplicate ratio. So duplicate, triplicate, subduplicate, subtriplicate. Okay, just for your understanding. Okay, so the ratio of the first and the third proportional, which is A by C, is equal to the duplicate ratio of the first and the second proportional, which is a square upon b square. Okay, this is also an important feature which we can use in some of the questions. Fine. Okay. Just to understand how this come, very simple. If you look at the right hand side, this can be written as a by b into a by b, right? And you know that a by b is equal to b by c. So if any of the a by b, you replace it with b by c, what do you get? This gets cancelled, and you can see that a by c on the left hand side and a by c is what you get on the right hand side, right? So basically not very difficult to figure this out. Okay, so let's look at a question here and understand this concept better. Okay, so Ram, Shyam and Prabhu have scored marks in ascending order such that their marks are in continued proportion. So basically Ram upon Shyam is to Shyam upon Prabhu. Okay, Shyam has scored 10 while Ram and Prabhu together have scored 29. So Ram plus Prabhu is 29. So let's say Ram is x, so Prabhu will be 29 minus x. Okay, so Ram is x, Shyam is 10, Shyam is 10 and Prabhu is 29 minus x. This will be my equation. Okay, so if I cross multiply, x into 29 minus x is equal to 100, or 29x minus x square is equal to 100, or x square minus 29x plus 100 is 0, or x minus 25, we are solving a quadratic equation, into x minus 4 is equal to 0. That means x is 4 or 25. That means Ram could have scored 4, Prabhu could have scored 25, or Ram could have scored 25 and Prabhu could have scored 4. So these are my two answers. The question is, how much has Ram scored? So which of these answers will you say? 4 or 25? Both of these are correct answers, right? Ram could have scored 4 also, Ram could have scored 25 also. But the hint is here. Ram, Shyam and Prabhu have scored marks in ascending order. That means an increasing order. So Ram has less than Shyam and Shyam has less than Prabhu. The marks are in increasing order. This is 10. So Ram must have less than 10. So between 25 and 4, you'll have to ignore 25 and you'll have to take 4. That means you'll have to give 25 here. Hence, Ram has scored 4 marks. Okay. And to see the proportion, Ram upon Shyam is 4 by 10 is equal to Shyam upon Prabhu 10 by 25. So if you cancel this, 2 by 5, and this also is 2 by 5. So you can see 2 by 5 is equal to 2 by 5. And hence that is your answer. Okay, so this is a classic example of continued proportion. Okay, let's look at one more question. If a plus b plus c, okay, a plus 2b plus c upon a minus c is equal to a minus c upon a minus 2b plus c, they are in continued proportion, then find the mean proportional between a and c. Okay, no option here but to cross multiply, and when you cross multiply you'll get 3 into 3, you'll get 9 terms, so you'll have to be slightly careful about the cross multiplication. So let's do that. A square minus 2ab plus ac plus 2ab minus 4b square plus 2bc plus c square. I should have done that first. Okay, no problem. C square minus 2bc plus ac. So my left hand side is done, is equal to right hand side is a minus c whole square. So a square plus c square minus 2ac. Okay, so this is, now let's see what of this, a lot of this should get cancelled. So minus 2ab plus 2ab plus 2bc minus 2bc. A square, c square, c square. That's all. So you get on the left hand side AC plus AC. That means 2AC minus 4b square is equal to minus 2AC, or 4AC is equal to 4b square, or b square is equal to AC. Now b square is equal to AC. That means mean proportional between A and C is B, because this tells you what? This tells you that A is to B is equal to B is to C. A, B, C are in continued proportion, and B is the mean proportional or the middle proportional or the second proportional. Hence the answer is B. Okay, so automatically it comes in this format. B square is equal to AC. That tells you that B is the mean proportional. Okay, so again, a classic example of continued proportion. Okay, let's look at one more. If B is the middle proportion between A and C, then which of the following is equal to A square plus B square upon B square plus C square? Okay, so again, if B is the middle proportion between A and C, then B square is equal to AC. Let's just subtract that here. So A square plus B square can be put as AC, and B square again can be put as AC plus C square. So from numerator, if I take A out, I get A plus C, and from denominator, if I take C out, I can write as A plus C. So AC is cancelled. My answer is A upon C. Right. But you can see here that A upon C, yes, A upon C is the first answer. So that clearly becomes my answer here. Okay, as simple as that. That's how your middle proportion or mean proportion can be applied, and we can get the required answer. Okay, so that's how these questions will be done. I hope we are clear with all this. Let's do one more question. This is slightly more interesting. If B is the middle proportion between A and C, same thing. So B square is equal to AC. Then which of the following is equal to? So we'll do the same thing again. But you can see here that you need B cube. Okay, so this is B cube minus 49 C cube A cube upon 49 minus 49 B cube. So B cube here, what do we do? B square we knew was equal to AC. Okay, B cube will be difficult because then you will have cube roots and all, which we don't want. So what do we do? Should we leave B there and replace A and C instead? Let's do that. If you see here, B square is equal to AC. That means A is equal to B square by A, or B square by C, sorry, or A cube is equal to B to the power 6 upon C cube. And similarly, C cube is equal to B to the power 6 upon A cube. Let's do this. So at least my roots will be avoided. So B cube will be as it is, minus 49 C cube, which is B to the power 6 upon A cube, upon A cube. So A cube is B to the power 6 upon C cube minus 49 B cube. Okay. And you can notice that B cube is common in all four. So B cube actually I can cancel, and then I will take LCM. So it will become A cube minus 49 B cube upon B cube minus 49 C cube. and then I'll have c cube upon a cube. So this is the fraction that I get. Okay, how do I solve this further? Yes, so how do we proceed from here? This is same as what we started with. In fact, this is slightly more complicated than that because this doesn't help us if you open this. So this may not be the best approach to solve this question, right? Let's try another approach. And this is important for you to understand, okay, this was my normal method, not very useful here because this complicates my work. So can I quickly switch and try another thing? Here you can see that you can't do anything from the answers also, right? The answers also are in values. So rather, let's do one thing. My cube is creating a problem. Okay, so let's do another thing. When I say that they're in continued proportion, what I mean by A by B is equal to B by C. Let's say this is equal to a constant. Okay, so that means A is equal to BK, and from the second one, B is equal to CK. Okay, let's use this. We are introducing a constant here. Okay, so my B cube minus 49C cube. Let's not touch the numerator right now. Let's change the denominator. So A cube is equal to B cube K cube minus 49. B cube is equal to C cube K cube. Okay. From the denominator, B cube minus 49C cube, let me take out K cube. Once I do that, I get B cube minus 49C cube. I get same value that was there in the numerator. That gets cancelled and I get 1 by K cube. That's my answer. But I don't have 1 by K cube. But you know that A by B is equal to K. So 1 by K is equal to B by A. 1 by K cube is equal to B cube by A cube. Right? But B cube by A cube you don't see in the answer. So let's take the second part. 1 by K is also equal to C by B. And hence 1 by K cube is also equal to C cube by B cube. And C cube by B cube I have. So that becomes my answer. Right? So sometimes introducing a constant also is fine. You can always eliminate that constant later. You know that your constant K is equal to A by B or it is equal to B by C, which is absolutely fine. Okay, that is better here because this cube will create a problem otherwise. It is not a round power. I know that I have B square. So B square, B to the power 4, B to the power 6, all that is fine. B to the power 3 will create a problem and hence we have used the concept of a constant here. Okay, so I hope you have understood this approach, and when you need to change your approach, you need to see, okay, this is not working out. This is getting more complicated. Let me switch. Let me move to another value or another method of attempting this. Fine. Okay, let's look at this. And here we have a root now. So if A, B, C, D are proportional, so first proportion, second proportion, third proportion, fourth proportion. So this is not continued proportion. Then which of the following are equal to 6a square minus 9b square upon 6c square minus 9d square? Okay, so in a continued in a regular proportion, we have a by b is equal to c by d, right? So A by B is equal to C by D. Fine. So what should we change here? What method should we try here? So here again, because the square and root and everything is involved, what might be a better approach is to use that constant once again. And we can say that A is equal to BK and C is equal to DK. Same thing that we had done in the previous question. So let's try this. Under root 6a square, which means b square k square minus 9b square upon 6 c square, which again is d square k square minus 9 d square. So from the numerator, you can see that b square is common and then the denominator d square is common. So I can take b by d out. So b by d, and then what am I left with? 6k square minus 9 upon 6k square minus 9. You have the same terms which get cancelled. So your answer is b by d. As simple as that. But b by d is not given to us. So what do we do? So you apply your what? Invertendo. B by d. So you can see alternando, in fact. Your b by d, we cross multiply them. So a by c is equal to b by d. So from your alternando, b by c, instead of b by c, you can say b by d. You can say a by c also, and a by c is given to you as an answer here. So we can use this to give us the answer for this question. Okay, so this is a regular proportion. A, B, C, D here are first proportional, second proportional, third proportional, fourth proportional, and that is how you solve. So this taking k as a constant is also a very useful approach which helps us in a lot of questions. And we should use that, especially when you have these squares and cubes and roots and those, which will make it more complicated. A very powerful method, and a method that will work in most of the cases. So please use this wherever required so that you can solve questions of this kind. Okay. So we'll do one last question here. We have to find the sum of the four ratios. We have w upon x plus y plus z is equal to x upon w plus y plus z, which is equal to, okay. So do you remember the sum wala property of proportion which we had discussed? Just to shake your memory once again, what we had discussed was, if you have a by b is equal to b by c, is equal to c by d, not a continued proportion but a regular proportion, is equal to e by f, then this is equal to a plus c plus e upon b plus d plus f. That is sum of all the numerators and sum of all the denominators. In fact, we also discussed that it is not necessary that you take all the numerators. You can just take first and the second numerator also. But if you take first and the second numerator, then you should take first and the second denominator also. So the corresponding denominators must be taken. You can take first and second, you can take second and third, or you can take first and third. That choice is completely yours. All this is fine. So using the same property, what we have been given here, let's just add all the numerators and all the denominators. So on the numerator side, you'll get equal to w plus x plus y plus z. And on the denominator side, you will see that you will get 3 w's. You will get 3x. You will get 3y. And you will get 3z. That means everything will be 3 times. 3 times w plus x plus y plus z. This will get cancelled and your answer will be equal to 1 by 3. As simple as that. Hence the sum of the four ratios will be equal to 1 by 3. Okay, and each ratio individually also is equal to, in fact, 1 by 3, right? Because this is equal to 1 by 3. So that is the answer for this question. Okay, so that brings us to the end of proportion. I hope you have understood all the concepts, understood all the questions that we have solved. And now I suggest you to revise whatever we have discussed in this class once again, solve the questions that we have done once again, and solve some more questions so that you are on top of proportion. See, proportion by itself may not give you enough questions in an exam, but proportion and ratio concepts will be used in multiple questions, be it time and work, be it time and distance, be it compound interest, simple interest, ratio, proportion, mixtures, allegations. Almost all chapters will use these concepts. So very, very powerful concept, and do practice them enough so that you're confident to apply is there. Okay. Thank you so much. See you in the next class. Bye-bye.